Hello, good evening, students. So let us start with the today's session. Yesterday we have started with electric potential and capacitor. Okay, so lastly we discussed one numerical. So today we are discussing first some two numericals examples, Nodana. Then we will start with the theory part. Okay. So here yesterday we discussed about what do you mean by electric potential, right? Then after that we have discussed. Okay. Yes. So you can see that is electric potential, the derivation for the electric potential due to an isolated charge we have discussed, correct? Yes. See here. So the second question, yesterday we discussed one question. So the second question is, two tiny spheres carrying charges 1.5 microcoulomb and 2.5 microcoulomb are located 30 centimeter apart. So you have a spheres. There are two spheres. One is having a charge of 1.5 microcoulomb and one is having a charge of 2.5 microcoulomb. They are located 30 centimeter apart. Okay, so the separation between the spheres is 30 centimeter. Find the potential and the electric field at the midpoint of the line joining the two charges. This is first calculation. The second calculation is at a point 10 centimeter from this midpoint in a plane normal to the line passing through the midpoint. So ಇಲ್ಲಿ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, so two calculation ಇದೆ ಆಯ್ತಾ. So ಎರಡು calculation ಮಾಡಬೇಕಾಗಿದೆ ನಾವು ಕ್ವಶನ್ ಅಲ್ಲಿ. You can see ಕೊಟ್ಟಿರೋ ಡಾಟಾನ ನೋಡಿ ನೆಕ್ಸ್ಟ್ ನಾವು ಏನನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ, ಏನ್ ಮಿಸ್ಸಿಂಗ್ ಇದೆ, ಏನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕಾಗತ್ತೆ. You can just check out. Okay, yes, start ಮಾಡೋಣ. So there are two spheres. They have given the charges as 1.5 microcoulomb and 2.5 microcoulomb. Correct. Then next here, the separation between the spheres, it is given. First in kelidare nodi, a question alli at the midpoint of the line joining the two charges. So you have to find the potential and the electric field. So both potential and the electric field we have to calculate. Here R1, R2. ಇಲ್ಲಿ ನೋಡಿ ಯಾವ ತರ ಬರುತ್ತೆ ಅಂತ. Here the distances, it is given as 30 centimeter apart. So the 30 centimeter apart, but from the midpoint you have to consider. Here one sphere you need to say, and here one sphere you need to say. This is the line joining of that. So from the midpoint, the total distance is 30 centimeter. Total distance is 30 centimeter. So from the midpoint, this distance will be one sphere ಗೆ distance 15 centimeter ಆಗುತ್ತೆ, ಮತ್ತೊಂದು sphere ಗೆ distance 15 centimeter ಆಗುತ್ತೆ. ಹಾಗಾಗಿ R1 is equal to R2 is equal to, it is 15 centimeter. So 15 centimeter if I convert, it will be 0.515 meter, right? So this is what the distance. The potential at the midpoint. So ಇಲ್ಲಿ midpoint ಅನ್ನ ನೀವು O ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ midpoint ಅಲ್ಲಿ ಯಾವ ರೀತಿಯಾಗಿ potential calculate ಮಾಡಬಹುದು ಅಂತ ನೋಡಿ. So here the potential at the midpoint is given by, so potential formula already you people know, ನಿನ್ನೆ ನಾವು ನೋಡಿದೀವಿ formula ಏನ್ ಬರುತ್ತೆ ಅಂತ. So therefore the potential at the O point ಅಥವಾ midpoint is equal to, this is 1/4 pi epsilon naught. Okay, so due to the two charges it is there, therefore it is Q1 divided by R2 minus Q2 divided by R1. Athwa Q1 divided by R1 and Q2 divided by R2 we can take. Okay, so now we can just substitute the values and simplify this one. This is equal to, so this is equal to 1/4 pi epsilon naught value is how much? It is 9 into 10 raised to 9. It is 9 into 10 raised to 9. Here the charge value is, one is having a charge of 1.5 microcoulomb and one is having a charge of 2.5 microcoulomb. So let us substitute that. So micro anta andre 10 to the power minus 6 baratte. Hagagi illi 1.5 into 10 to the power of minus 6 divided by the distance is 0.15. Okay, minus. So minus, what is the other charge? It is 2.5 into 10 raised to minus 6 divided by 0.15. Yes, you can try the simplification. So inside the bracket, first you try to simplify, then you can simplify the multiplication part. So whatever the 10 to the power of minus 6 is there, the 10 to the power of minus 6 ಇಲ್ಲಿ ಬರಿಕೊಳ್ತಾ ಇದ್ದೀನಿ. That is 9 into 10 to the power of 9. 10 raised to minus 6 common ಇದೆ. So therefore take it outside. Inside the bracket you will be having 1.5 divided by 0.15. And here it is 1.5 divided by 0.15. So just try to simplify this one. See here, this 1.5 can be written as 15 divided by 10 and 0.15 can be written as 15 divided by 100. So see, that is V naught is equal to 9 into 10 to the power of 9 into 10 to the power of minus 6. So inside the bracket we have 1.5 upon 0.15 minus 1.5 upon 0.15. Okay. So this is nothing but 9 into 10 to the power of 9 and minus 6. So 9 minus 6 will be 10 to the power of plus 3. Then next here this can be written as. So decimal ಅಲ್ಲಿ ಯಾರಿಗೆ simplification easy ಆಗುತ್ತೆ decimal ಅಲ್ಲಿ ಮಾಡ್ಕೊಳ್ಳಿ. ಯಾರಿಗೆ tough ಆಗುತ್ತೆ you can try with fraction method. So ಇದನ್ನ ratios ಆಗಿ convert ಮಾಡ್ಕೊಳ್ಳಿ simplification easy ಆಗುತ್ತೆ. 1.5 can be written as 15 divided by 10 and this 0.15 can be written as that is 100 divided by 15 divided by 100. So it will be 100 divided by 15, right? And here it is minus. Again here also same, that is 15 by 10 into 100 divided by 15. Correct? So you can just simplify this one. Try ಮಾಡ್ತಾ ಇದ್ದೀರಾ? Or else you can also try with this method also. The LCM will be 0.15. ಆ ತರ ಕೂಡ ಮಾಡಬಹುದು. ಯಾರಿ ಯಾವ ರೀತಿಯಾಗಿ ಈಸಿ ಆಗುತ್ತೆ you can proceed with that step. So I am telling you all the methods. So the LCM will be same. So if the LCM is same, you can also write it as 0.15. Here it is. Sorry, this charge is 2.5, right? So one charge 2.5 ಇದೆ. One charge is given as 1.5 microcoulomb and one more charge is given as 2.5 microcoulomb. Sorry, other charge is 2.5. 0 baralla, answer 0 baralla. Because one charge is 1.5 and one charge is 2.5. So here we will have minus 1 upon 0.15. Minus 1 upon 0.15. Then next here you can simplify it as what? That is V naught is equal to, that is 9 into 10 raised to 3. And here this minus you keep it as it is. And this is divided by 0.15. I can write it as 100 upon 15. Correct? So 9 threes are, that is 3 threes are 9. 3 fives are. So it is 3 by 5. 3 by 5 is nothing but what? 3 divided by 5 will be 0.6. So this is 0.6 into 10 to the power of 3 and this is 2 10 to the power of 5 volt. So it is 0.6 into 10 raised to 5 volt. Yes. Correct? Okay, students. So the next is what? At a point 10 centimeter from this midpoint in a plane normal to the line and passing through the midpoint. Okay, so first simplification, hope so it is clear to you. So the second part of the simplification, what they are asking in the second part of the simplification, at a point 10 centimeter from this midpoint. So again midpoint ittu. Here we can consider the two charges. So from this midpoint, here the 10 centimeter they are saying. Okay, so this total is 30 centimeter, this total is 30 centimeter. So here it is 15 centimeter and here it is 15 centimeter. So this is 10 centimeter, 15 centimeter. Hagadre il distance estagutte nodi. Here the resultant, this is what? From the midpoint in a plane normal to the line, in a plane normal to the line they are saying. So normal to the line anta andre what you need to consider here? You have to consider normal to the line. Okay, so this is 10 centimeter and this is 15 centimeter. So we need to calculate what is the value of, this is the sphere. Okay, so this distance we have to calculate. So here this is r1 is equal to r2 is equal to, so this is a right angle triangle, so we can apply the Pythagoras theorem to calculate the value of this r1 r2. r1 r2 value will be equal. Hauda, so e value enagatte, erdu value equal agatte. B calculation I am doing. Okay, B part calculation. So see here, so now r1 and r2 will be what? That is equal to under root of 10 square. This is under root of 10 square plus 15 square, under root of 10 square plus 15 square, which is equal to under root of 325. So 10 square is 100 plus 15 square, it is 225. So total it is 325. So under root of 325, so the square root of 325 is 18 centimeter. So now the distance is how much? It is 18 centimeter. Okay, now we can calculate the resultant potential due to this. So the resultant potential is given by, this is equal to, so common is 1 upon 4 pi epsilon naught, and inside the bracket this is q1 by r1 and plus q2 divided by r2, q2 divided by r2. Okay, so you can just try it as a homework, you just check. So previous ಏನ್ ಮಾಡಿದ್ವಿ ಅದೇ ರೀತಿಯಾಗಿ ಮಾಡಬೇಕು. 1 upon 4 pi epsilon naught value is 9 into 10 raised to 9. Q1 value is 1.5 microcoulomb, Q2 value is 2.5 microcoulomb, and the distance is 18 centimeter. 18 centimeter ಅನ್ನ ಮೀಟರ್ ಅಲ್ಲಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ 0.18 meter ಅಂತ ಬರುತ್ತೆ. Okay, so this one you try it, students. I am going for the next question. Yes, see the next question. Hope so the question is visible to you. See, a point charge of 6 into 10 raised to minus 8 coulomb is located. It is located in air. Find the electric potential at a point distance 1 millimeter from the charge and at a point distance 1 meter from the charge. So here you need to calculate the value of the potential. Okay, see how to do this one. Same method. A point charge, so the value of the charge is given as 6 into 10 raised to minus 8 coulomb, which is located in air. Find the electric potential at a distance. So first distance estanta helidare, it is given as 1 millimeter. So 1 millimeter will be what? 1 into 10 raised to minus 3 meter, or simply 10 raised to minus 3 meter. And the next question, second part ಅಲ್ಲಿ ಏನ್ calculate ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದರೆ, now the distance is how much? It is 1 meter. I'll just read out the question if it is not visible. So here the question is, a point charge of 6 into 10 raised to minus 8 coulomb in air, find the electric potential at a distance of 1 millimeter from the charge and at a distance of 1 meter from the charge. So simple, charge they have given 6 into 10 raised to minus 8 coulomb. And first potential calculate ಮಾಡಿ 1 millimeter distance ಅಲ್ಲಿ, second calculation 1 meter distance ಅಲ್ಲಿ calculate ಮಾಡಬೇಕಾಗಿದೆ. Hope so. Question is clear to everyone. I am just writing the answer here. See, the potential is equal to 1 upon 4 pi epsilon naught Q by R, or simply ನೀವು ಇದನ್ನ KQ by R ಅಂತ ಬರ್ಕೊಳ್ಳಿ. So K value is how much? It is 9 into 10 raised to 9 into the charge value ಕೊಟ್ಟಿದ್ದಾರೆ, that is 6 into 10 raised to minus 8 upon the R value. So R value is how much here, students? 1 millimeter. So 1 millimeter is 10 raised to minus 3 meter. So this is first simplification. Similarly, the second simplification, second question ಅಲ್ಲಿ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ? In the second question, they are asking to calculate the potential at a distance of 1 meter. So again, same, it is 1 upon 4 pi epsilon naught Q by R. And here the value is 9 into 10 raised to 9 into 6 into 10 raised to minus 8 upon 1 meter ಅಂತ ಹೇಳಿದ್ದಾರೆ ಈಗ. ಸೊ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ 1 millimeter ಅಂತ ಹೇಳಿದ್ರು, ಸೆಕೆಂಡ್ ಅಲ್ಲಿ 1 meter ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಎಸ್, ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಟ್ರೈ ದ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್. ಎಸ್, ಇಫ್ ದ ಕ್ವಶನ್ ಇಸ್ ನಾಟ್ ಕ್ಲಿಯರ್, ಐ ಜಸ್ಟ್ ರೀಡ್ ಔಟ್ ದ ಕ್ವಶನ್. ಹೇಳಿದೀನಿ ಕ್ವಶನ್ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ. ನಾವಿಲ್ಲಿ ಬರೀ ಈಗ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡ್ಬೇಕಾಗಿದೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ. ಸೊ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ನೋಡಿ, ದಟ್ ಇಸ್ ಓನ್ಲಿ ಪವರ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್, ಯು ಜಸ್ಟ್ ಡೂ ಇಟ್. ಸೊ 9 6 30, that is 54, 9 6 it is 54 into 10 to the power of 9 minus 8. So 9 minus 8 will be plus 1. This minus 3 ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ plus 3 ಆಗುತ್ತೆ. So plus 3 plus 1, that is plus 4. So 10 to the power of 4 volt. So 54 into 10 raised to 4 volt or 5.4 into 10 to the power of 5 volt. So ಇಲ್ಲಿ just multiply ಮಾಡಿ, that is 9 into 6 is 54. 10 raised to 9 ಇದೆ, 10 raised to minus 8 ಇದೆ. So that will be 10 raised to plus 1. So 10 raised to plus 1 is nothing but 54 into 10 is 540 volt. Yes, if any doubt is there, please ask. I am going for the theory part now. Yes, bari derivation ಹೇಳಿದ್ರೆ you feel bored. So I have taken some numericals. Okay. Clear? Yes, I'm going for the theory part. Yes, numerical is clear, no? I am just starting with the theory part. Answer is 54 into 10 to the power of 4 volt or 5.4 into 10 to the power of 5 volt. First case ಅಲ್ಲಿ. Second case ಅಲ್ಲಿ answer ಏನ್ ಬರುತ್ತೆ? In second case, you are getting answer as 540 volt. Is it clear now, students? Okay. So the first derivation, very small derivation I am taking. Then we will start with equipotential surface. Done. Question read ಮಾಡ್ದೆ ಅಲ್ಲ ನಾನು, ಬರೀ ಚಾರ್ಜ್ ವ್ಯಾಲ್ಯೂ ಮತ್ತೆ ಡಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ ಅಷ್ಟೇ ಕೊಟ್ಟಿದ್ದಾರೆ, ಮತ್ತೇನಲ್ಲಿ ಏನ್ ಬಿಗ್ ಕ್ವಶನ್ ಏನಿಲ್ಲ. Okay, so I am just starting with the theory part. So here we are discussing the relation between the electric field and the potential. ಆಯ್ತಾ? So electric field ಮತ್ತೆ potential relation ಅನ್ನ ನೋಡೋಣ. What is the relation between them? So electric field ಅನ್ನ E ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ, potential ಅನ್ನ V ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. ಹಾಗಾದ್ರೆ ಎರಡರ ಮಧ್ಯದಲ್ಲಿ ರಿಲೇಷನ್ ಯಾವ ರೀತಿಯಾಗಿ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನ derivation ಮೂಲಕ ನೋಡೋಣ. So see here, whatever the relation is there, again it is important for 2 mark question ಅಂತ ಹೇಳ್ಬೋದು. Or in the fill in the blanks, we will get that. See. Okay. So the relation between, we are doing the relation between that is potential and the electric field E. Okay. So how to do the relation between them? There are two methods. So ನಾನು just ಒಂದೇ method ಹೇಳ್ತಾ ಇದ್ದೀನಿ because ಎರಡು method ಹೇಳಿ ಆ derivation half, ಈ derivation half ಬರ್ದಿ, you will not come to the conclusion only. So only one derivation we are discussing. Okay. So see how to do the derivation. So for the derivation, we have our simple diagram here. We are taking 2 points, that is A and B. So this is our B point and this is our A point. Here the distance between these 2 points, it is taken as, that is dx. So the distance between the points, it is taken as dx. Okay. So here we are taking a charge plus q, and the electric field for the plus charge will be in the outward direction. Electric field will be in the outward direction. Okay. So see here. So consider A and B be the 2 points which is separated by a distance of dx. So illen kottidare, that is A matte B point ide, adra madhyadalli distance ettide, that is the distance between them is dx. Okay. So here q naught or q is the unit positive charge. So q is the unit positive charge. Here we will consider dv as, dv is what? It is the potential difference. Nan pd anta barkolta idini students illi. So dv is the potential difference between A and B. It is the potential difference between A and B. Potential difference between A and B. And here dx is the distance. Okay. Dx is the distance between A and B. Right. So as we know that from the basic definition, so il potential anna ನಾವು ಏನಂತ ತಗೊಂಡಿದ್ದೀವಿ, we have taken the potential as dv, right? So potential dv is equal to, we know that potential is equal to what? It is work done in bringing a charge from A to B. It is the work done per unit charge. So according to the definition of the potential, we can write it as dw upon q naught. Okay. So ninne nodidvi, hope so you remember that one. Potential is equal to work done per unit charge. So ನಾವು ಇಲ್ಲಿ ಏನು ತಗೊಂಡಿದ್ದೀವಿ, potential ಅನ್ನ dv ತಗೊಂಡಿರೋದ್ರಿಂದ dv ಮತ್ತೆ work done, small work done we are considering, that is the dw, right? So dv is equal to dw upon q naught. Okay. So work done is equal to formula in Bharati students. We know that the work done is equal to force into displacement. So write that work done is equal to force into displacement. I'm introducing here minus sign. I'll tell you why this minus sign is there. So dv is equal to minus f into dx upon q naught. Okay. Now, see, minus f into dx upon q naught, because we know that work done is equal to force into displacement. So now we'll negative sign anna tagolta idivi. Why there is a negative sign? Tell me. Because we are moving a charge and the electric field are in the opposite direction. So illen displacement ಆಗ್ತಾ ಇದೆ, the displacement of the charge and the electric field both are in the opposite direction. Therefore we have here negative sign. Electric field and the displacement are in the opposite direction, therefore the negative sign we have. So minus f into dx divided by q naught. Okay. So again, ಇಲ್ಲಿ ನೋಡಿ students, what is force by charge is called as? ಯಾರಾದ್ರೂ ಹೇಳ್ಬೋದಾ? What is the force divided by charge is called as? Force upon charge anna ಏನಂತ ಹೇಳ್ತೀವಿ? Force per unit charge. If you tell me, the derivation will end here only. What is force by charge? Yes, correct. Very good. So force by charge is called as what? Electric field. So electric field E into dx. So the relation between the electric field and the potential is given by E is equal to minus dV divided by dx. So this is the relation between potential and the electric field. Again, this is a 2-mark question. Yes, any doubt is there? I told you already there are 2 methods to do this one. So simple agiro method anna nanu ಇಲ್ಲಿ explain ಮಾಡಿದೀನಿ. Okay, done. So the relation between electric field and the potential is given by E is equal to minus dV divided by dx. Okay. So ಇಲ್ಲಿ ಏನ್ ನಾವು quantity ಬರ್ದಿದೀವಿ students, that is dV divided by dx. This dV by dx is called as potential gradient. ಈ term ಅನ್ನ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ? This term is called as what? Potential gradient. Okay. This term is called as what? Potential gradient, right? So here the negative sign also indicates there is a decrease in the potential. There is a decrease in the potential. Okay. So what is the conclusion of this derivation? What is the meaning of this term? That is the electric field matte illen potential ide. The magnitude of the electric field is equal to the negative potential gradient. Okay, so you need to remember the meaning also. The magnitude of the electric field is equal to the that is negative potential gradient, right? So what is potential gradient? That dV by dx quantity is called as what? Potential gradient. The rate of change of potential with respect to the distance is nothing but the potential gradient. Okay. And remember, this derivation is applicable for the non-uniform electric field also. Non-uniform electric field also, the derivation is applicable. Okay, students, if this is clear, I am going for the next point. Very simple derivation, 2 marks. The next point we are discussing is equipotential surface. So what is equipotential surface? I think the one and only theory concept in this lesson anta helbodu. Baki alla kade maximum derivations baratte. See here. What is equipotential surface? As the term indicates, equi antandre en heli, equi means what? It is equal. Equi means it is equal. Potential. So already potential we have studied. So equal potential, we can say it as what? Equal potential, right? So here equal potential, new definition on a screen mel nodbodu. A surface which have same electrostatic potential at every point on it is known as what? That is equipotential surface. So equal potential. Adanne sentence al barbitre definition aitu. The surface which have same electrostatic potential at every point on it is known as what? Equipotential surface. So what you can understand from the definition? Suppose if I consider yavado one random ag one surface ide anta assume madi. So here on each and every point, so if you consider here, illi, yalli neevu tagondrunu, yav point mele tagondrunu, the potential is equal. Suppose ee surface potential 5 volt ide anta andre, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲೂ 5 ವೋಲ್ಟ್ ಇರುತ್ತೆ, ಇಲ್ಲೂ 5 ವೋಲ್ಟ್ ಇರುತ್ತೆ, 5 ವೋಲ್ಟ್ 5 ವೋಲ್ಟ್ 5 ವೋಲ್ಟ್ 5 ವೋಲ್ಟ್ 5 ವೋಲ್ಟ್ means at each and every point on the surface the potential is equal. So such type of surfaces are called as what? Equipotential surface. Done. So what is equipotential surfaces? The surfaces which are having the same electrostatic potential at each and every point on that is known as what? Equipotential surface. Okay. So the equipotential surface here, the example for the equipotential surface you can consider as, that is all the charged surfaces. All the charged surfaces you can consider it as what? Equipotential surface anta navilli helbodu. All the charged surfaces are called as what? That is the equipotential surface. Okay. Done. So next important point is again 2 marks or sometimes for the 3 mark. What are the properties of the equipotential surfaces? So what are the properties of the equipotential surfaces? You can see there are 4 points we have written there. Okay, so one by one we will try to understand that. Yes. So the first point regarding the equipotential surfaces do not intersect with each other. Equipotential surface ಏನಗಲ್ಲ, they never intersect with each other ಅಂತ ಹೇಳ್ತೀವಿ. Okay. So what is the meaning that they never intersect with each other? It means that why it will not intersect and what is the meaning of that intersection. See, equipotential surface andre naven helidvi. So this is one surface anta assume ಮಾಡಿ. Okay, so this is a equipotential surface andre ella point mele andre ella point of the surface is having the same potential. One more surface I'll consider. ಇದೊಂದು equipotential surface ಇದೆ. Suppose this is having the potential equipotential ಅಂದ್ರೆ potential value 2 volt ಇದೆ and this is having the potential 4 volt. So one surface iddu potential 2 volt ಇದೆ, this is having this potential 4 volt. So both are equipotential surface. First statement ಏನ್ ಹೇಳ್ತಾ ಇದೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ, the equipotential surfaces do not intersect with each other. They never intersect with each other. Why they never intersect with each other? See, so this is having 2 volt, this is having 4 volt. Intersect ಆಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಏನ್ ಮೀನಿಂಗ್ ಆಗತ್ತೆ? At one particular point they are meeting together, right? So intersect ಆಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ರೆ, so this is one surface, this is one surface, right? ಯಾವ್ದೋ ಒಂದ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಪಾಯಿಂಟ್ಸ್ ಇರ್ಬೋದು, ಬಟ್ ಅಟ್ ಲೀಸ್ಟ್ ಮಿನಿಮಮ್ ಒನ್ ಪಾಯಿಂಟ್ ವಿಲ್ ಬಿ ದೇರ್ ವೇರ್ they both are joining together. ಹೌದಾ? So at which point both are joining together ಅಂದ್ರೆ ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗಿದೆ ಆ ಪಾಯಿಂಟ್ ಪೊಟೆನ್ಶಿಯಲ್ ನೀವು ಎಷ್ಟು ಅಂತ ಹೇಳ್ತೀರಾ? ಹೌ ಮಚ್ ಇಸ್ ದ ಪೊಟೆನ್ಶಿಯಲ್ ವ್ಯಾಲ್ಯೂ ವೇರ್ ದೇ ಆರ್ ಇಂಟರ್ಸೆಕ್ಟಿಂಗ್ ವಿತ್ ಈಚ್ ಅದರ್? One is having the potential 2 volt and the other surface is having the potential 4 volt. So ಎರಡು potentials ಬೇರೆ ಇದ್ದಾಗ at the point of intersection, what is the potential value? Whether it is 2 volt or 4 volt, whether it is 4 plus 2 or 4 minus 2. How to decide that? That is not possible. Suppose ನೀವು ಅದನ್ನ ಡಿಸೈಡ್ ಮಾಡ್ತಾ ಇದ್ದೀರಿ ಅಂತ ಅಂದ್ರೆ then it is not called as the equipotential surface. Why it is not the equipotential surface? Because equipotential surface definition ಏನ್ ಹೇಳುತ್ತೆ? The potential is equal at each and every point. So ಎಲ್ಲಾ ಬಾಡಿ ಫುಲ್ ಬಾಡಿ ಮೇಲೆ 2 volt ಅಂತ ಇದ್ದಾಗ ಅದು ಒಂದೇ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ that is 4 volt or any other value if it is there, ಆ ಸರ್ಫೇಸ್ ಅದು equipotential surface ಕಂಡೀಷನ್ ಅಥವಾ ಡೆಫಿನೇಷನ್ ಅನ್ನು ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಲ್ಲ. Then it is not called as the equipotential surface. Understood why they never intersect with each other? This is the reason. Okay, so first property is the first characteristics of the equipotential surface. Equipotential surfaces do not intersect with each other as it gives two directions of electric field E at intersecting point, which is not possible. So one reason ಏನಾಗುತ್ತೆ, a point of intersection ಅಲ್ಲಿ what is the potential value that you cannot determine. Second thing is what, here whatever that equipotential surface is there, it gives the direction of the electric field. So again equipotential surface ಇದೆ that is giving the direction of the electric field. Okay, ಹಾಗಾದ್ರೆ when they are intersecting, so idondu potential surface ide that is 3 volt, one more is having the potential of 5 volt. So one is having as 3 volt, one is having as 5 volt. If they intersect with each other, so this is having the direction, electric field direction in the one direction, this is having the electric field in the other direction. Suppose idu plus charge 3 coulomb ide, idu minus 5 coulomb iddaga the direction, electric field direction will be different. So when they intersect, you cannot determine. Understood, students, why it is not intersecting? Going for the next point. Equipotential surfaces are closely spaced in the region of strong electric field, vice versa. So what is vice versa? That is, adu closely spaced irutte very if strong electric field ide, where there is a weak electric field, they are away from each other. That is the meaning of the closely spaced region of the strong electric field and the other definition. So let us see this one, or let us understand this. You can just tilt that one screen, ನಿಮ್ಮ mobile screen ಅನ್ನ ನೀವು ದೊಡ್ಡ ಮಾಡಿ ನೋಡಿದ್ರೆ you can read out what it is displayed on the screen. ನೀವು screen small ಇಟ್ಕೊಂಡು ನೋಡಿದ್ರೆ ನಿಮಗೆ ಕಾಣಿಸಲ್ಲ, you will be complaining it is not clear, it is not clear. Enlarge ಮಾಡಿ ನೋಡಿ. Okay, tilt your screen and see. Then only you can read out. Yes. When you tilt your screen, you are able to see that one properly. ನಿಮ್ಗೆ ಅಲ್ಲಿ ಚಾಟ್ಸ್ ಓದ್ಬೇಕಂತ ಇದ್ರೆ ಬೇರೆಯವ್ರ ಚಾಟ್ಸ್ ಓದ್ಬೇಕಂತ ಇದ್ರೆ then you have to keep it both the screen on. Yes, just tilt it, only enlarge that PPT and you just see that one. You can see what it is written. Okay. Second point explaining. Okay, going for the second point, students. See here, that is equipotential surfaces are closely spaced for the strong electric field. See here, when I draw the electric field lines, suppose if I have one is positive charge and this is also the positive charge. So L2 positive charge idag enagatte, as we know that the electric field lines will be outward in direction. The electric field lines will be outward in direction. So this is also same, idku kuda outward in direction. The electric field lines will be outward in direction, right? So equipotential surface with respect to this one, when I take, this will be here. Illi enagatte, illi equipotential surface irutte. So for this charge, this will be here. Illi enagta ide, that is, this is weak electric field. This is weak electric field. So weak electric field irodrinda equipotential surfaces ಎರಡು ದೂರ ದೂರ ನಮಗೆ ಕಾಣಿಸ್ತಾ ಇದೆ. They are away from each other. So when I take one is plus charge and one is negative charge, ಅವಾಗ ಏನಾಗುತ್ತೆ? So for one, this will be moving outward and for one, it will be moving inward. And also, the electric field line starts from the positive charge and it will end at the negative charge, right? So ಈ ರೀತಿಯಾಗಿದ್ದಾಗ ಇಲ್ಲಿ ನಮಗೆ electric field lines closely spaced. We are able to see the electric field lines are closely spaced. In that case, the equipotential surfaces are coming closer to each other. Getting my point? So when you have the weak electric field yavag form agate? When you have the two similar charges, right? So when you have the two unlike charges, this is forming the strong electric field. So strong electric field iddaga equipotential surfaces are closely spaced. When you have the weak electric field, equipotential surfaces are away from that. Compared to the first one, this is away. Understood? Second point, hope so it is clear. Third point, very simple point. Electric field is always normal to the equipotential surface at every point of it and directed from one equipotential surface at highest potential to the equipotential surface at lowest potential. So electric field ಅನ್ನೋದೇನಿದೆ for the equipotential surface, this is normal to the surface. It is normal to the given surface. Okay. Then the next one is equipotential surface. On the equipotential surface, the work done is zero. The work done in moving a test charge from one point to the other point is zero. So why the work done is zero? See here, students. Yak work done zero agate? Sometimes 2 marks ಅಲ್ಲಿ explain ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳ್ತಾರೆ. Okay, so ಯಾಕೆ ನಾವಿಲ್ಲಿ explain ಮಾಡಿ ಹೇಳ್ತಾ ಇದೀವಿ ಎಲ್ಲ characters ಅಥವಾ properties ಅನ್ನ? Sometimes in 2 marks they will ask you to explain why equipotential surfaces do not intersect with each other. Justify or explain how the electric field lines are strong, or when the electric field lines are strong enough, the equipotential surfaces are closely spaced. So with diagram, you need to explain. Okay, why the work done is zero on the surface of the equipotential surface? Yes. So ee ರೀತಿಯ question ಕೇಳಿದಾಗ you need to answer that one properly. So for that reason, you need to understand the explanation part. See here. So yak work done zero irutte? We know that potential is equal to what? Work done per unit charge. Potential is equal to work done per unit charge, right? So hagadre work done is equal to expression enagatte? Work done is equal to V into Q. Work done is equal to V into Q, right? So equipotential surface. So here, if I consider the equipotential surface, So this is one equipotential surface. Here different points are there. I'll consider ಎರಡು point ಅದರಲ್ಲಿ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. One I'll take it as VA and one more point I'll take it as VB. So there are 2 points I'm considering, VA and VB. So potential difference ಯಾವ ರೀತಿಯಾಗಿ ಬರಿತೀವಿ? The potential difference is written as what? That is VA minus VB into Q. Okay. So what is the value of the equipotential surface? VA value. Suppose idu potential estide ee surface danta andre the potential value is 8 volt. Okay. Idu ಒಂದು equipotential surface ಇದೆ, ಅದರ value 8 volt ಇದೆ. So 8 volt ಇದ್ದಾಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? Both are having the same value. VA is also 8 minus VB is also 8 because it is a equipotential surface. 8 minus 8 will be 0. So ಹಾಗಾದ್ರೆ work done ಎಷ್ಟಾಗುತ್ತೆ? It will be 0. Understood? So with example I have given, ನೀವು exam ಅಲ್ಲಿ ಯಾವ ರೀತಿಯಾಗಿ explain ಮಾಡಬೇಕಾಗುತ್ತೆ? On the equipotential surface, as the potential values are equal at each and every point, so the potential difference will be 0. When the potential difference will be 0, the work done will be 0 for the equipotential surface. Clear? Yes. So fourth point ಅನ್ನು justify ಮಾಡ್ಲಿಕ್ಕೆ take the help of the definition. Okay. So moving forward, students, the next point. So after completion of the equipotential surface, the relation between electric field and the potential, we are going to proceed with the next point, that is the potential energy. So potential energy, again, we have the derivations here. Yes, see this equipotential surface example. So this is 3-dimensional figure, you can see. So first ನೀವಲ್ಲೇನ್ concentric circles ಕಾಣ್ತಾ ಇದ್ದೀರಾ ಅಲ್ಲಿ. So you have first equipotential surface that is having the value 10 volt. Other next in circle ಇದೆ that is having the value 9 volt, 8 volt, 7 volt, like that it will continue. Okay. Next, again you can see the next figure. So that is also what? Again 1111 plates ಕಾಣ್ತಾ ಇದೆ ನಿಮಗೆ, ಅದು equipotential surfaces. And also you can see the electric field lines. Again ನಿಮಗೆ yellow line ಕಾಣಿಸ್ತಾ ಇದೆ students. ಎರಡು figure ಅಲ್ಲಿ whatever the yellow line you are able to see, that is nothing but the direction of the electric fields. Yes. So first figure, the positive charge is there moving outward and which is also perpendicular to the equipotential surface. Second figure, what you are seeing, that is also same. That is minus andre allen first plate in ಕಾಣಿಸ್ತಾ ಇದೆ ನಿಮಗೆ, that is the negative charge. So the electric field lines are moving towards that. You can see for the surfaces, the electric field lines are normal to the surface, right? Okay, students, the next one, that is the electric potential energy. Electric potential energy. So already you have studied about the potential energy, ಎಲ್ರಿಗೂ ಗೊತ್ತಿರುತ್ತೆ. So potential energy is nothing but the energy in the stored form. The stored energies are called as what? Potential energy. So this here we are dealing with electric potential energy. ಇಲ್ಲಿ ನಾವೇನ್ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದೀವಿ? Electric potential energy. So see, what is electric potential energy? Electric potential energy of a system of point charges. It is defined as the work done in assembling this system of charges from an infinite distance apart from one another. So ನಾವೇನ್ potential define ಮಾಡಿದ್ವಿ, so ಇಲ್ಲೂ ಕೂಡ almost same ಬರುತ್ತೆ. That is nothing but it is the amount of work done in assembling the charges. So the charges are at infinite distances. So charge ಎಲ್ಲ ಎಲ್ಲಿದೆ? Infinite distance ಅಲ್ಲಿದೆ. We are bringing those charges to a finite distance. So whatever the work done you are doing, that is nothing but the electric potential energy. That is nothing but electric potential energy. Okay, so the electric potential energy is defined as it is the work done in bringing the charges from infinite to the given positions. Okay, so here let us see the first derivation. Two derivations I am taking here. Yes. Let us see the first derivation, students. The first derivation we are doing, that is the expression. The expression for the potential energy. So the expression for the potential energy of a system of a system of 2-point charges, of a system of 2-point charges in absence of electric field. So ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ ನಾವೇನ್ ಎರಡು ಡೆರಿವೇಶನ್ ಮಾಡ್ತಾ ಇದೀವಿ. One we are doing it for absence of the electric field, and one derivation we are doing it for the presence of the electric field. Which one once again you are asking? So here we are doing the derivation, right? Okay. So which one you will say once again? Please specify that point, students. ಯಾವ್ದು ಮತ್ತೊಂದ್ಸಲ explain ಮಾಡ್ಬೇಕಂತ ಹೇಳ್ತೀರಾ ಅದನ್ನ ಸ್ಪೆಸಿಫೈ ಮಾಡಿ. ನಾವಿಲ್ಲಿ ಈಗ ಡೆರಿವೇಶನ್ ಮಾಡ್ತಾ ಇದೀವಿ. We are doing the derivation for what? Potential energy of a system of 2-point charges in the absence of the electric field. In absence of the why work done is zero. Why work done is zero? What I told you, that is, if you consider any one equipotential surface, on the equipotential surfaces, potential is equal at every point. So this equipotential surface is having a potential of 5 volt. So when I say it as a 5 volt, here this is also 5 volt, and yavade point anna tagoli. If you consider this point 5 volt, this point 5 volt, this is also 0.5 volt, here also 5 volt, ella point allu 5 volt irutte. Okay, here the work done is given by, the work done is given by what? That is VA minus VB into Q. Why this is the expression? This also we know, that is potential is equal to work done by charge, therefore work done is equal to potential into charge. But why we are taking VA minus VB? Because potential difference ತಗೊಳ್ಬೇಕಾಗತ್ತೆ, ಹೌದಾ? So VA pointal potential, if it is 5 volt, what is the VB potential? This is also 5 volt into Q, whatever may be the charge. 5 into 5, 5 minus 5 will be how much? It is 0. Hagadre work done enagatte 0. Gottaita? So here what we can justify, or what we can explain here, on the equipotential surface, the potential value is equal at each and every point. Therefore, the work done will be 0, because the potential difference will be 0. When the potential difference is 0, the work done will be 0. Yes, hope so now it is clear. Okay. So I am going for the derivation. As I told you, we are doing the expression for the electric potential energy in the absence of the electric field. Remember, in the absence of the electric field. So nim screen alli en kanista ide, you are not able to see anything now, right? So you just imagine I am getting one charge from infinite distance to this screen. So infinite distance ಅಲ್ಲಿ ಒಂದು charge ಇದೆ, ಆ distance ಇಂದ ನಾನು ಇಲ್ಲೊಂದು charge ತಗೊಂಡು ಬರ್ತಾ ಇದ್ದೀನಿ. So when I bring that charge here, directly I can just keep the charge here. Okay, so Q1 is that charge which I am keeping it at a point A, right? So Q1 is the charge which I am keeping it at point A. So ಯಾವಾಗ ನಾನು ಆ ಚಾರ್ಜ್ ಅನ್ನು ಸ್ಕ್ರೀನ್ ಮೇಲೆ ತಗೊಂಡು ಬರ್ತಾ ಇದ್ದೀನಿ, I am not facing any opposition. Why there is no opposition? Because as on that screen there is no positive charge, there is no negative charge, nothing is there to oppose. Suppose ಅಲ್ಲಿ already one positive charge ಇದ್ರೆ, which I am getting the charge, that is also positive. So ನಾನು ತಗೊಂಡು ಬರೋ ಚಾರ್ಜ್ ಕೂಡ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ. So already ಇಲ್ಲೊಂದು ಚಾರ್ಜ್ ಇತ್ತಂದ್ರೆ ಏನಾಗ್ತಿತ್ತು? There will be opposition, because we know that from the properties of the charges, what we know, the like charges will repel each other. Like charges will repel each other, and unlike charges will attract each other, right? So ಇದು ಯಾವಾಗ repel ಮಾಡತ್ತೆ, the work done will be different. But there is no charge on the screen, so there is no opposition for that. So the figure is somewhat like this. Here we have the point A, here we have the point B, and here we have the charge Q1, and here we have the charge Q2, and these two are separated by a distance of R. Okay, so imagine you are getting some charge from infinite distance to the given point. That is only potential energy, hodala? So the charge Q1 and Q2, first we are getting it from infinite distance. right? So the expression, so let us write the derivation. First step, what we are writing, that is the electric potential at B due to Q1 is given by, due to Q1 is given by V1 is equal to, this is V1 is equal to 1 upon 4 pi epsilon naught Q1 divided by R. Correct, students? So the potential at B. So potential at B barita idivi due to Q1 charge. So due to Q1 charge in barate, it will be V1 is equal to 1 upon 4 pi epsilon naught Q1 upon R. Q1 upon R. So this is equation 1. Okay, the next one. So next, when you are getting the charge Q2, next ನೀವು ಯಾವಾಗ Q2 charge ಅಂತ ತಗೊಂಡ್ ಬರ್ತಾ ಇದ್ದೀರಾ from infinite distance. So that time already ನಿಮ್ಮ ಹತ್ರ Q1 ಇರೋದ್ರಿಂದ there will be some electric field because whenever you have a charge, there will be the presence of the electric field, right? So there is a presence of the electric field. So Q1 ಏನ್ ಮಾಡುತ್ತೆ, it will try to oppose the Q2 charge due to its electric field, right? ಹಾಗಾದ್ರೆ ನಾವು ಅಲ್ಲೇನ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ, we need to do some external work. That work done is equal to V into Q2. It is V into Q2. So what is that V? V is nothing but what? V1. V is nothing but here V1. ಹಾಗಾದ್ರೆ V1 value ಏನಿದೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ? This V1 value is 1 upon 4 pi epsilon naught. It is 1 upon 4 pi epsilon naught Q1 by R into Q2, and this work done is stored in a body as what? In a charge as what? That is the potential energy. So the potential energy U is equal to, the expression is 1 upon 4 pi epsilon naught Q1 into Q2 divided by R, where R is the distance between the charges. Very simple derivation. So baro chances kadme, but just nimge gottirli. Right? Okay, so this is the electric potential due to, not due to, that is in absence of the electric field. So why we are saying in absence of the electric field? So there is no charge. First we are getting one Q1 charge. So for that Q1 charge, what is the potential? That is V1 is equal to 1 upon 4 pi epsilon naught Q1 by R. Okay. So when you are getting the Q2 charge, Q2 ತರಬೇಕಾದ್ರೆ already Q1 ಇರೋದ್ರಿಂದ some external opposition will be there. So that time here we need to do some work, and that work is given by V1 into Q2. ಹೌದಾ, ಯಾವ ಚಾರ್ಜಿಂಗ್ ಮಾಡ್ತಾ ಇದೀವಿ? Q2 ಮಾಡ್ತಾ ಇದೀವಿ, ಹಾಗಾಗಿ ಇಲ್ಲಿ Q2 ಬರುತ್ತೆ. And V1 value already we have from the equation 1, substitute, and this work done is stored in a body as what? Potential energy. Therefore potential energy is equal to 1 upon 4 pi epsilon naught Q1 into Q2 by R. Done? Okay, hope so there is no confusion here, students. I'm going for the next derivation. Done. Okay, the next derivation is, in absence of the electric field nodidvi students. Next we are seeing it for the presence of the electric field. So the derivation is for the presence of the electric field. So let us see how to do in presence of the electric field. So for this figure we can take it as this is Q1, this is Q2. Here the potential is V1, here the potential is V2, and the electric field lines is outward in direction. The point A and the point B. These are separated by a distance of R. So here in the above figure, Q1, Q2 are the two charges. VR is the distance between them. V1 and V2 are what? V1 and V2 are the potential at point A and B respectively. So here one step only, that is the potential for this surface is given by. See, directly we can write now. The potential energy of the system of this charge is given by the potential energy of system of charges is given by the potential energy is equal to. So first, the potential energy in absence of electric field, in absence of electric field, plus potential energy of Q1 at A plus potential energy of Q2 at B. Okay, so only two step it is there, that is potential energy of the system is given by. So why we are specifying it as a system? So illenagatte students anta andre, so previous case alli namdu screen mele enu charge irlilla, but here already on this screen we have the electric field. Okay, so for this electric field, here we are getting the two charges. So first we are getting one charge Q1 and then next we are getting the other charge, that is Q2. Right. So first we are writing the expression for what? The potential energy of the two charges in absence of the electric field. So in absence of the electric field, what is the potential value? In absence of the electric field, the potential is given by 1 upon 4 pi epsilon naught Q1 into Q2 divided by R. 1 upon 4 pi epsilon naught Q1 into Q2 divided by R plus potential energy of Q1 at A. So at A is given by what? It is Q1 into V1 plus at B it is given by what? Q2 into V2. This is the total potential energy of the system in presence of the electric field. In presence of the electric field. Yes. Okay. So going for the next point, students. See if any doubt is there, please ask. Okay, students. Next one. See, the next point we are discussing, please continue the next topic. I'll leave this topic and I'll start next topic. Okay, see, so first part complete agatte. Here we will finish the first part. Electrostatic shielding, polar molecules, non-polar molecules. Then we will go for the capacitor part. Okay, so that will be the end of the class, don't worry. Another one class, after that we will go for the next chapter. So what is electrostatic shielding here? Electrostatic shielding, as the term again it states, shielding. So shielding means what you can imagine, that is you are protecting yourself or you are protecting something. See that what it is, the process which involves the making of a region free from any electric field is known as electrostatic shielding. So what is electrostatic shielding? The process which involves the region which is making free from the electric field. So if you are not understanding this one, so if you are not understanding this, just imagine one thing. So consider, as you can see now in some places there is a rain. So ಕೆಲವೊಂದ್ ಕಡೆ ಮಳೆ ಆಗ್ತಾ ಇದೆ, ಕೆಲವೊಂದ್ ಕಡೆ ಆಗ್ತಾ ಇಲ್ಲ, whatever it is. So during the rainy season, here what you can see, that is lightning process, right? So during the rainy season, you can see the lightning process. So during this lightning and thunderstorm, what we say, that is we need to keep ourselves protected from that phenomena, right? It is a natural phenomena. So during that, what we need to do, we need to protect ourselves. So to protect ourselves, what we can do, now ಏನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ? So either ನಾವು ಮನೇಲಿದ್ರೆ we have to stay in the home, or if you are traveling, so suppose if you are traveling by car, you have to be in the car. So whatever it is, you during this lightning process, you need to keep yourself safe. Why they say you need to keep yourself safe? Because in lightning process, it is nothing but the discharge of the charges taking place. Discharge of the charges from where? From the clouds. Okay, so clouds in the charges discharge ಆಗ್ತಾ ಇರುತ್ತೆ. So that process is called as what? That is the lightning process. That process is called as the lightning process. These are nothing but the electric field lines. These are nothing but the electric field lines. Okay, so because charge is there, so whenever there is a charge, there will be an electric field. So when there is an electric field, as you know that human body is a good conductor of electricity, right? So sometimes during that rainy season, what happens, if you are not protecting yourself from this lightning process, there is a chance that you may die also due to this process, right? So ಅದಕ್ಕೋಸ್ಕರ ನಾವ್ ಏನ್ ಮಾಡ್ತೀವಿ, we say that the ಮಳೆ ಆಗ್ಬೇಕಾದ್ರೆ ಹೊರಗೆ ಹೋಗ್ಬೇಡ ಅಂತ ಹೇಳ್ತಾರೆ. You should not stand under the tree. Why? Because here you are protecting yourself from those electric field lines, right? So this is nothing but what? Electrostatic shielding. ನೀವೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ನಿಮ್ಮನ್ನ ನೀವು ಫ್ರೀ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀರಾ. From where? From those electric field lines. So this process is called as what? Electrostatic shielding. Understanding? Suppose whatever the region or another one vastu ide, this you need to keep it away from the electric field lines. You need to keep it in a box or anything. So which is an insulator. ಆ ತರ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, here the electrostatic shielding ಅನ್ನ ನಾವಿಲ್ಲಿ assume ಮಾಡಬಹುದು. The process which involves the making of a region free from any electric field is known as what? Electrostatic shielding. It is called as electrostatic shielding. Okay, so you can see one example there, explanation. It happens due to the fact that no electric field exists inside a charged hollow conductor. Yes, we know that. So as we know that the charges reside only on the surface, ಒಳಗಡೆ ಇರಲ್ಲ, ಹೌದಾ? Inside the body, we don't have any charge. The charges will reside only on the surface. Only on the surface, the charges will be there, right? So potential inside a shell is constant. In this way, we can also conclude that the field inside the shell will be zero. So remember, always we can say that the electric field inside a body will be zero. Why it will be zero? Because the charges will reside only on the surface. Charge bari elliratte, surface mele matra iratte, not inside the body. So when the charges are not there inside the body, electric field inside the body will be what? Zero. So electrostatic shielding al nav ಏನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬಹುದು, that is inside the hollow cylinder or anything. So hollow conductor, anything inside the body, the electric field will be zero. Okay. Why? Because inside we don't have any electric field lines, as there is no charge. The process which making us free from this electric field lines is called as what? Electrostatic shielding. Okay. The next point in this chapter, that is the dielectrics. So here we have two types of dielectrics, that is the polar dielectrics and the non-polar dielectrics. So first, let us understand what is dielectrics. Okay. Lightning means during rainy season. So ಮಳೆ ಬರ್ಬೇಕಾದ್ರೆ ಏನಾಗತ್ತೆ? ಗುಡ್ಗು, ಸಿಡ್ಲು, what you call it? Yes, regarding the subject, if anything is there, you chat here. Don't waste energy. Okay. So next point, student. Done. So what is dielectrics here, students? Dielectrics nothing but it can be described as, so you can imagine these dielectrics as, that is insulators. Okay. Or you can call it as what? That is poor conductor, very poor conductor of electric current. Such materials are called as what? That is dielectrics. They're basically insulators and contain no free electrons. So obviously, so insulators ನಮ್ಗೆ ಗೊತ್ತಿದೆ, conductors, insulators ಅಲ್ಲಿ ಏನಂತ ಹೇಳ್ತೀವಿ? There is no free electrons. So when there is no free electron, the electric current is not possible. So dielectrics can be easily polarized when an electric field is applied to it. So insulators ಗೆ ಮತ್ತೆ dielectrics ಗೆ ಏನ್ ಡಿಫರೆನ್ಸ್ ಅಂತ ಅಂದ್ರೆ, ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮಟೀರಿಯಲ್ ಏನಿದೆ, ಓಕೆ, ಸೊ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮಟೀರಿಯಲ್ಸ್ ಅನ್ನ ನೀವು ಇಲ್ಲಿ ಕಂಡಕ್ಟರ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬಹುದು. ಹೌ ಯು ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ಇಟ್ ಟು ಕಂಡಕ್ಟರ್ಸ್? ಬೈ ಪೋಲರೈಸಿಂಗ್ ದಟ್. ಹೌ ಯು ಕ್ಯಾನ್ ಪೋಲರೈಸ್ ದಟ್? ಬೈ ಅಪ್ಲೈಂಗ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಸಪೋಸ್ ಇಮ್ಯಾಜಿನ್, ಸೊ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮಟೀರಿಯಲ್ಸ್ ಗೆ ಒಂದ್ ಎಕ್ಸಾಂಪಲ್ ಅಂತ ಅಂದ್ರೆ ಮೈಕಾ ಅಂತ ಒಂದ್ ಮಟೀರಿಯಲ್ ಇದೆ. ಓಕೆ, ಸೊ ಮೈಕಾ ಅಂತ one material ಇದೆ. This mica comes under what? Dielectrics. So this mica or this material, when you want to polarize it, you just need to keep it in an electric field. Okay, so this is positive charged plate and this is the negative charged plate. So as you know that electric field will start from positive plate to the negative plate. Mica material anna, when you keep it inside the electric field, here ಇದೇನಿದೆ dielectric ಇದೆ, but it will start acting like a conductor. So you can polarize that and you can make it as a conductor. Their behavior in an electric field is entirely different from that of conductors. So it will just conduct, but it is not similar to the conductors. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸೊ ಇದು ಇನ್ಸುಲೇಟರ್ಸ್ ಆಗಿ ಬಿಹೇವ್ ಮಾಡತ್ತೆ, ಬಟ್ ನೀವು ಇದನ್ನ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಇಟ್ಟಾಗ ಪೊಲರೈಸ್ ಆಗಿ it will somewhat starts behaving like a conductor, but it is not exactly showing the properties of the conductors. Understood? Okay. Which one to repeat? Which one you want me to repeat? Yes, dielectrics. Is it clear? Electrostatic shielding, dielectrics. Any doubt is there in this? How you have different materials like glass, plastic, similarly we have ಮೈಕಾ. ಓಕೆ, ಸೊ ಯಾವ ರೀತಿಯಾಗಿ ಗ್ಲಾಸ್ ಇದೆ, ಪ್ಲಾಸ್ಟಿಕ್ ಇದೆ, ಸಿಮೆಂಟ್ ಇದೆ, ಈ ತರ ಯಾವ ರೀತಿಯ ಬೇರೆ ಬೇರೆ ಮಟೀರಿಯಲ್ಸ್ ಇದೆ. ಲೈಕ್ ದಟ್ ವಿ ಹ್ಯಾವ್ ಒನ್ ಮಟೀರಿಯಲ್ ಕಾಲ್ಡ್ ಆಸ್ ಮೈಕಾ. ಓಕೆ, ವಿಚ್ ಈಸ್ ಅ ಡೈಎಲೆಕ್ಟ್ರಿಕ್. ಸೊ ವೇರ್ ವಿ ಕ್ಯಾನ್ ಯೂಸ್ ದಿಸ್ ಮೈಕಾ, ದಟ್ ಇಸ್ ಥರ್ಮಲ್ ಇನ್ಸುಲೇಷನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಫೀಲ್ಡ್ ಕಾಯಿಲ್ ಇನ್ಸುಲೇಷನ್ಸ್, gauge glass. So different uses are there for mica in electronics. Okay, in drilling muds, like that we have different uses of the mica. So as I told you, there are two types of the dielectrics, that is polar molecule and the non-polar dielectrics. So polar dielectrics and the non-polar dielectrics. So before going to understand what is polar molecule and polar dielectrics and the non-polar dielectrics, which definition? If it is showing the property of the conductor, we will call it as a conductor. Dielectrics are the different materials. Distilled water also comes in the dielectric. Dry air, vacuum, nitrogen, helium, ceramic. These are all dielectrics. Like that, we have one material called as mica. Now, is it clear? Okay, going for the next point, students, that is the types of the dielectrics. So before going to understand the types of the electrics, here we have polar molecules and non-polar molecules. So this only later we differentiate it as polar dielectrics and the non-polar dielectrics. Okay, so see here, that is polar molecule. What do you mean by the polar molecule? Actually, in chemistry, we study about the polar molecule. Here, in case of the polar molecules, we have the center of gravity of the positive charges and the negative charges do not coincide with each other. So in case of the polar molecules, here what happens? That is, for example, you will examples anna nodabodu. That is HCl is there, H2 is there, N2O, NH3, H2S, C2H5OH, SO2. These are example for the polar molecules. So in the polar molecules, here the positive charge and the negative charge. Okay, so if you consider HCl, so this is H, this is Cl, the center of these two charges, they do not coincide with each other. They do not coincide with each other. So such type of materials or the molecules are called as what? Polar molecules anta heltivi. So polar molecules ige ನೀವು examples ಅನ್ನ ನೋಡಬಹುದು. Okay, so these molecules are having the permanent electric dipoles. So why they have the permanent electric dipoles? See here. So polar molecule ಏನಾಗತ್ತೆ ಅಂತ ಅಂದ್ರೆ, here whatever the positive and the negative charges are there, they are separated here. ಹೌದಾ? So ನೀವು electric dipole ಅನ್ನ ಯಾವ ರೀತಿಯಾಗಿ define ಮಾಡ್ತೀರಾ? Dipole is nothing but what? Two unlike charges are separated by some distance, right? So already it is separated by distance. So therefore, these are having the permanent electric dipoles. These are having the permanent electric dipoles. Correct? Okay, so the non-polar molecules will be having the opposite definition. Here, what happens in case of the non-polar molecules, whatever the positive and the negative charges are there, they are not separated from each other. So the positive and the negative charges are coinciding each other. They are coinciding with each other. They do not have the permanent dipole moment. So obviously, they are to coincide adaga, now in here bodu, we cannot show here any dipole moment. So permanent dipole moment is not there. What are the example for the non-polar molecules? That is CO2, CCl4, oxygen, nitrogen, hydrogen, methane, ethane. These are the example for the non-polar molecules. Yes. So the dielectrics made from the polar molecules are called as polar dielectrics. And the dielectrics made up of the non-polar molecules are called as what? Non-polar dielectrics. Yes, any doubt is there here? The polar molecule, non-polar molecule, or polar dielectrics, non-polar dielectrics. Okay, so proceeding towards the next point, students, that is the capacitor. So what do you mean by capacitor, capacitance? So today we will just see the introduction part of the capacitor. Then the derivation we will do in the next class for the capacitors. Okay, so see, what do you mean by the capacitor? Capacitor is nothing but what? It is a device. Okay, so capacitor annodeniide, it is a device. So till now what we have studied? Till now we have studied, that is screen, whatever. If the screen is not clearly visible, I'll write whatever I am explaining. Don't worry. Okay. Okay. Yes. See, capacitor. So till now we have discussed about the charge. How the charge and now we cannot leave the charges anywhere in the surfaces ಅಥವಾ ಅದೇ ರೀತಿಯಾಗಿ ನಾವು ಇಲ್ಲಿ ಬಿಟ್ರೆ wherever we require how to use that one. So to store the charges, what is required? Some device is required. So capacitor is a device which is used to store the charges. So charge ಅನ್ನ store ಮಾಡ್ಲಿಕ್ಕೆ ನಾವು ಏನ್ device ಅನ್ನ use ಮಾಡ್ತೀವಿ, that device is called as what? Capacitor. So in the physics lab, if you visit, you can see the capacitors will be there. So capacitor is what? It is a device which uses or which stores the charges in it, ಹಾಗಾದ್ರೆ capacitance ಅಂತಂದ್ರೆ ಏನಂತ ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ. So capacitance is nothing but what? The capacitance of a conductor, it is the ability of the conductor to store the charges on it. So ನಾವು ಈಗ ಏನಂತ ಹೇಳಿದ್ವಿ? Capacitor means what? It is a device which store the charges. Capacitor ಏನ್ ಮಾಡತ್ತೆ? Charges ಅನ್ನ store ಮಾಡತ್ತೆ. Which store the charges. Okay. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಮತ್ತೊಂದು ನೆಕ್ಸ್ಟ್ ಟರ್ಮ್ ಅನ್ನ ಡಿಫೈನ್ ಮಾಡ್ತಾ ಇದೀವಿ, that is the capacitance. Capacitance ಅಂತ ಅಂದ್ರೇನು? It is the ability. Okay. It is the ability. It is the ability to store the charge. Ability to store the charges is called as what? Capacitance. So capacitor is a device which is used to store the charges. Capacitance is what? It is the ability. Andre capacitance. So for example, what is the capacitance of you? So capacitance of you to study. Capacitance ಅಂತಂದ್ರೇನು? Capacitance ಅಂತಂದ್ರೆ how much you will study. ನಿಮ್ಗೆ ಎಷ್ಟು ability ಇದೆ ಸ್ಟಡಿ ಮಾಡೋದು. So that is, so for the capacitor, it is having some ability, ಇಷ್ಟೇ ಚಾರ್ಜ್ ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡ್ಕೊಳ್ಳೋದಂತ ಇರುತ್ತೆ. So that ability of the device or the ability to store the charge is called as what? Capacitance. And the device is called as what? The device is called as what? Capacitor. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಎರಡು ಟರ್ಮ್ ಬೇರೆ ಇದೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡಿ. Capacitor is a device to store the charge. Capacitance is the ability to store the charge. Understood? Hope so. The definition is clear to you. Capacitor is a device which stores the charges. Capacitance is the ability of the conductor to store the charges. Okay. Yes. So what we said, just one point we will discuss. Last other expression matte units anna discuss madana. See. So capacitor ಏನ್ ಮಾಡುತ್ತೆ? ಚಾರ್ಜ್ ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳಿದ್ವಿ. ಹಾಗಾದ್ರೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ? ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. So the charge, how much the capacitor is storing, that charge is denoted by Q. This is directly proportional to the potential. So ಎಷ್ಟು ಚಾರ್ಜ್ ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ, that depends on the potential of the surface. So the charge is directly proportional to the potential, that Q is equal to CV. Q is equal to C into V, where C is the proportionality constant and the C is called as what? Capacitance of the capacitor. ಈ C ಅನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? It is called as capacitance of the capacitor. Capacitance of the capacitor, right? C is the capacitance of the capacitor. V is the potential. Q is the charge. ಹಾಗಾದ್ರೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನ್ ಬರುತ್ತೆ? Q is equal to CV ಅಂತ ಹೇಳ್ತೀವಿ. Q is equal to CV. We can also write this as Q is equal to CV as C is equal to Q divided by V. C is equal to Q divided by V, right? So this is the capacitance expression. C is equal to Q by V. Okay. So remember the points regarding the capacitor, the formula. So definition nodidvi, what is capacitance? What is capacitor? What is the expression for the capacitor? C is equal to Q by V. The next point is unit. The unit of the capacitor is farad. The unit is what? It is farad. The unit of the capacitor is farad. Or we can also write it as coulomb per volt. It is also written as coulomb per volt. So dimension formula kuda gottirli students nimge. Please note down this dimension formula. Very, very important. Yaryar idralli CET, NEET, JEE exam an baribekanta madkondidira. So capacitor, the dimension formula is m to the power -1, L to the power -2, T to the power 4, A to the power 2. I'll write it once again. The dimension formula. Okay, so the capacitance dimension formula is given by m raised to -1, L raised to -2, T raised to +4, A raised to 2. So this is the dimension formula of the capacitor. Okay, unit already I told you, it is farad and it is a scalar quantity. So it is a scalar quantity. The dimension kuda ide, unit kuda ide. Yes, any doubt is there regarding the capacitor or capacitance? Okay. Done, students. So in the next class, we will see the derivations of the capacitors. So in the capacitor, we have series, parallel combination, series combination, energy stored is deleted. So then derivation barala. Another 4 derivation and Van de Graaff generator. So this much we need to cover in the next class. Okay. So screen mela lane ide that I have written side. Unit, definition, formula, and the dimensions. Okay, students, we will meet in the next class and we will continue with the derivations and Van de generator graph, which completes the lesson. Okay, thank you.